Have you ever thought about, what it would be like to have a computer that could, like, solve problems in seconds that would take our current computers, like, thousands of years?
Wow.
Like, crazy stuff, like cracking codes that are supposed to be unbreakable, or designing new medicines, or even being able to predict climate change, like, super accurately.
Yeah.
Well, that's kind of the whole promise of quantum computing. And get this, scientists might be one step closer because of a crazy new discovery. They've created something called split electrons.
It does sound pretty sci-fi, right?
Yeah.
But the implications of this are really real, and they could totally change the entire field of quantum computing.
That's what we're diving deep into today. We've got this super interesting article from scitechdaily.com. It's called Scientists Create Split Electrons, Unlocking the Future of Quantum Computing. And it was published pretty recently, actually, just last week on January 9th, 2025. So get ready, because we're going to learn what these split electrons actually are, how they're connected to this mind-bending concept called quantum interference, and why scientists are so excited about these things called Majorana fermions.
Yeah, Majorana fermions are really at the heart of why this is such a big deal. They could be what we need to build much more stable and reliable quantum computers. And that's something that's been like a major hurdle in the field.
Okay, so let's unpack that a bit. So the article starts off by talking about electrons, those super tiny particles we all learned about back in school. We were always taught that they're fundamental, indivisible particles. But now scientists are saying that they can be split.
Right.
How is that even possible?
Yeah, it really is kind of mind-boggling when you think about it in those terms.
Yeah.
But what's actually happening isn't that we're literally breaking these electrons up into smaller pieces.
Oh.
It's all happening at like the nanoscale, where the behavior of electrons is governed by these really strange rules of quantum mechanics.
Nanoscale, so we're talking like super tiny.
Exactly. Imagine if you could shrink a wire down to the point where it's only a few atoms wide.
Wow.
The electrons in that wire are kind of forced to interact with each other in very strange ways.
So it's the extreme miniaturization that's making the electrons act so weird.
Yeah, that's a big part of it. And that's actually where things start to get really interesting, because at this size, the electrons start to show these quantum behaviors like interference.
Okay, the article mentioned quantum interference, and that sounds like something straight out of Star Trek.
Well, it's a real thing, and it's actually been observed for a long time.
Oh, wow.
So the classic example of this is the double slit experiment. So picture this. You're shining a beam of electrons at a barrier, and this barrier has two super tiny slits in it.
Okay.
And behind the barrier, there's a screen that can detect where the electrons land. Now, using common sense, you'd think you would see two bright spots on the screen, right? One for each of the slits.
Yeah, that's what I would think.
But that's not what happens. You actually see this pattern of like alternating bright and dark bands, and it's called an interference pattern. It's almost as if the electrons are behaving like waves coming out of the slits and kind of like bumping into each other.
So the electrons are kind of acting like they're going through both slits at the same time?
Yeah.
What?
It's one of the weirdest things about quantum mechanics. Particles can kind of act like waves, too. Each electron goes through both slits at the same time, and that's what makes that crazy pattern on the screen.
Okay, wow, my mind is officially blown. But how does that relate to split electrons?
So in this new research, scientists have found a way to create a similar kind of interference pattern. But this time, they're not using two physical slits. They're using the interactions between multiple electrons that are packed together super tightly in a nanoscale circuit.
So instead of physical barriers, it's the electrons themselves that are making the interference.
Exactly. And because of that, the way these electrons behave together, it's like watching one single electron that's been split into two different parts. And we call that a Majorana fermion.
So these Majorana fermions, they aren't actually particles, are they?
Right.
They're more like some sort of emergent property of the electrons all working together.
That's right. It's kind of like a big group of fish all moving together in the same pattern.
Yeah.
It looks like one giant thing from far away, but it's really just a bunch of smaller things all moving together in the same way.
That's a really good analogy. Okay, so we've got these split electrons, or Majorana fermions, and the article says that they're like the holy grail for quantum computing. Why are they so special?
What makes Majorana fermions so cool is that they're actually their own antiparticles.
Okay.
And that has big implications when it comes to stability.
Yeah.
See, in the quantum world, everything's super fragile, and it's easy to mess things up with just a little bit of noise from the environment. But since these Majorana fermions are their own antiparticles, they're much more stable. It's like trying to build a house out of bricks that can't be shaken by earthquakes.
So they're like super strong building blocks for quantum computers.
Yeah.
That sounds like it could solve a ton of problems.
Yeah, it could. One of the biggest problems with building a quantum computer is keeping these delicate quantum states going long enough to do a calculation.
Right.
But if we could build a quantum computer with Majorana fermions,
Yeah.
it'd be way more resistant to errors and noise.
That's amazing. But how do they actually make these Majorana fermions in a lab? They mentioned forcing electrons together. What does that even mean?
It basically means that they create very specific conditions inside of a nanoelectronic circuit.
Okay.
This usually involves a combination of really special materials, crazy low temperatures, and magnetic fields that are really carefully controlled. You have to remember that all this is happening in the quantum world.
Yeah.
So we have to be able to control everything perfectly, even down at the atomic level.
So it's not as easy as just connecting some wires and boom, you've got Majorana fermions popping out.
Not quite.
Oh.
It takes a lot of really complicated equipment and a really deep understanding of quantum mechanics to create the right conditions.
Okay, so it sounds like we're still in the really early stages of this research, but the potential is huge. And this new discovery about creating Majorana fermions in nanoelectronic devices could be totally revolutionary for quantum computing.
It's definitely a big step forward, for sure.
Yeah.
What this research is doing is opening up this completely new way to explore and manipulate Majorana fermions. And that could be how we get to the next generation of quantum computers.
So we've got this awesome discovery, but where does it fit in the bigger picture of quantum computing? What kind of an impact could this have on us in the future?
That's a great question. And that's actually exactly what we're going to be talking about in the next part of our deep dive.
Stay tuned, everyone. We're going to be exploring just how big of a deal this discovery could be. We'll be right back.
All right, so we've got these split electrons, these Majorana fermions, and everyone's saying they could revolutionize quantum computing. But, like, what does that actually mean for the future? Like, what can we actually do with it?
Well, that's the exciting part, right? The applications of quantum computers that use these stable Majorana fermions are basically endless. Like, imagine what we could do in medicine.
Yeah.
We could simulate how molecules interact with each other with unbelievable precision.
Okay.
That could let us develop personalized medicine that's made specifically for you based on your genes, or even help us find cures for diseases that we have no way to treat right now.
So we could be talking about a world where, like, Alzheimer's or cancer just don't exist anymore?
Yeah, it's definitely possible. And it goes way beyond medicine, too. Imagine being able to use quantum computers to design brand new materials that have properties that we haven't even thought of yet.
We could build things out of lighter and stronger materials that would be way more sustainable. Or we can make solar panels that are super efficient and revolutionize how we use renewable energy.
I've heard a lot of people talking about how quantum computing could be really important for AI, too. Could these split electrons help us create smarter AI?
Totally. Quantum computers are amazing at solving certain types of problems that regular computers really struggle with, especially problems that involve complicated patterns or that need to be optimized.
Okay.
And that makes them super powerful for machine learning and could lead to huge AI breakthroughs that we can't even imagine right now.
So we could have AI that can understand and respond to human emotions, or even AI that can compose music that's as good as the best human composers.
Yeah. The possibilities are kind of limitless when you have that much computing power.
Yeah.
But you have to remember that there are still challenges that we need to figure out.
Oh.
Even though Majorana fermions make things more stable, building a quantum computer that can handle a lot of information and isn't affected by errors is still super complicated. We're still learning how to control these crazy particles.
So we shouldn't expect to have quantum computers in our homes anytime soon.
Probably not.
But
we're making a lot of progress, and people are investing tons of money in quantum computing research. Big companies like Google, IBM, and Microsoft are all in this race to build the first useful quantum computer. And discoveries like this split electron thing are getting us closer to that goal.
It's all really exciting, but just like with any new powerful technology, we have to think about the downsides too, right? Like, are there any potential problems with quantum computing?
You're right. It's super important to think about the ethics, too.
Yeah.
One of the biggest concerns is what it could mean for cybersecurity.
Yeah.
Quantum computers could potentially break the encryption that protects everything we do online, which would be a disaster for privacy and security all over the world.
So all our personal information, bank stuff, everything online could be at risk.
That's the worry. But the good news is that scientists are already working on new encryption methods that quantum computers can't break. It's a race against time to make sure our data stays safe as quantum computers get stronger.
It sounds like we're entering a whole new world of cybersecurity. But even with these risks, it seems like the possibilities of quantum computing are just too big to ignore.
I think so too.
Yeah.
Imagine if we could use quantum computers to model climate change in a way that we've never been able to before.
Yeah.
That would let us figure out the best ways to deal with it.
Right.
Or what if we could simulate how new drugs work at the molecular level?
Mhm.
Could you create life-saving treatments way faster? Quantum computing opens the door to all of that.
I know, it's hard not to get excited about all of this. But let's get back to this discovery we're talking about today. Just how big of a deal is this split electron breakthrough for quantum computing research?
It's a huge step forward for sure.
Yeah.
Remember, one of the biggest problems with building a quantum computer is being able to keep these quantum states going long enough to actually use them. But since these Majorana fermions are their own antiparticles, they're way more stable than other quantum bits that people are using.
So could this research be the key to creating a new kind of quantum computer that's much more stable and reliable than anything we have now?
We're hoping so. We're still in the early stages, and there's so much more we need to learn. But this discovery could be what changes everything. It gives us a new way to create and control these particles. And that could lead to a future where quantum computers are more than just something in a lab. They're tools that change the world.
Okay, so we talked about what these split electrons are and how they work those Majorana fermions that could totally change quantum computing.
Right.
But I think the really mind-blowing part is thinking about why this matters.
Yeah.
Like, what kind of crazy future could this tech unlock?
It's almost impossible to imagine right now.
Yeah.
What if we had quantum computers that could model really complicated systems, like so accurately that we could predict and control stuff like the weather or how diseases spread? We could have medicine that's personalized for every single person that works at the molecular level, and maybe even cures diseases that we thought were incurable.
So we're talking about potentially solving some of the biggest problems we have, like climate change, not having enough food, pandemics.
Yeah, the potential is definitely there. Quantum computers could help us invent new energy sources, create transportation that's super efficient, even come up with sustainable farming to feed the whole world.
It's kind of hard to even wrap your head around all the things we could do. But, okay, let's say we could just snap our fingers and have a quantum computer right now, like a big, powerful one. What problem would you want to solve first?
Oh, man, that's a tough one. There are so many things we could do.
Yeah.
But, I think I'd try to understand the human brain.
Really?
Yeah, imagine being able to, simulate how the brain works down to the tiniest quantum level.
Okay.
We can finally figure out what consciousness is, where creativity comes from, and what intelligence really is.
That's pretty ambitious. We could finally understand what makes us human, what makes us think and feel the way we do. I mean, that would change how we think about psychology, neuroscience, maybe even philosophy.
Right. It's this problem that's been bugging scientists and philosophers forever, and quantum computing could finally be how we solve it.
But let's be real for a second. We're still a long way from having quantum computers that can do something like simulate the human brain. This split electron research is definitely a step in the right direction, but what are the next big things scientists need to figure out?
One of the biggest things is scalability.
Okay.
Right now, we're just playing around with a few of these Majorana fermions. To build a really powerful quantum computer, we need to be able to create and control thousands or even millions of them.
Right.
And they all need to work together perfectly. And that's going to be a huge engineering challenge.
And even if we could build these massive quantum computers, how would we even tell them what to do?
Yeah.
Writing quantum algorithms is totally different, right?
Oh, yeah. It's a completely different way of thinking about computing. It's like learning a whole new language, a quantum language. And it's the only way to use the weird but powerful rules of quantum mechanics.
So it sounds like the future of quantum computing is going to depend on more than just physicists and engineers. We're going to need mathematicians and computer scientists, too, to come up with the tools and algorithms to actually unlock the potential.
It's definitely a team effort. It's bringing together the smartest people from all these different areas, and that's what makes it so cool. It's like a giant collaboration that's pushing the limits of what we know and what we can do as humans.
Well, it's been amazing exploring this world of split electrons and quantum computing. It makes you really think about all the possibilities and makes you super curious about what the future is going to be like.
I think that's the best part of learning about stuff like this.
Yeah.
You walk away feeling that sense of wonder and wanting to learn even more. And for anyone out there who's now totally fascinated by quantum computing, there's tons of great stuff out there you can check out.
Oh, yeah, for sure. You mentioned the Quantum Computing Report website earlier. It's got great news and analysis.
Yeah.
And for those who are ready to get into the really technical stuff, Nielsen and Chuang's book, Quantum Computation and Quantum Information, is a classic.
Yeah, those are great places to start. And, of course, always keep an eye on those science publications like scitechdaily.com to see the latest discoveries.
Right.
Things are moving so fast in this field, and I'm sure there are going to be tons of exciting new breakthroughs soon.
Well, on that note, we're going to wrap up this deep dive into the super fascinating world of split electrons and quantum computing.
Yeah.
A huge thank you to our expert for taking us on this wild ride.
It's been awesome talking about all this with you.
And to all our listeners out there, stay curious, keep exploring, and always remember the future is quantum.